So the second part of the titration questions, that a student is investigating a reaction between potassium manganate and a metallic salt. About 1 cm cube of sodium hydroxide is added. It's giving a green precipitate. So what this gives an idea, because it's an iron salt. Iron 2 is dirty green and iron 3 is red brown. So it's green precipitate. It means iron salt is there. Or it might be a chromium salt as well. A burette was filled with potassium manganate and 25 cm cube of solution A. So in the burette, we have potassium manganate. So there is a burette which is filled with potassium manganate, and the conical flask is filled with solution A, which is 25 cm cube of salt solution. Then we add potassium manganate is added and taken. So what is the appearance? What is the color of potassium manganate? Potassium manganate is itself, it is purple, but when it mixed with the solution, it turned pink. So originally in the burette, it is purple because high concentration. When we add potassium manganate, react with the metal, so there is no color. Initially, there is no color. Once all of the metal used up, like if iron 2 was there, all of the iron 2 used up, then this potassium manganate will not react and the solution will turn to be pink. So originally there is no color because potassium manganate reacted with iron. But once all of the iron is used up, iron 2 is used up, the potassium manganate will show up pink color. So we can identify that all of the iron used up, and we can identify what volume of potassium manganate is needed to react with this 25 cm cube of solution A. So this is the final burette reading, which again we read from top to bottom. So 25, this is 26 exactly. Then experiment 2 was repeated by using solution B of a salt, not solution A. So it means the unknown solution is in a conical flask. So for solution B, we repeat the experiment. 25 cm cube of solution B was there. And from the burette, how much? Originally it is 16 and then 29. So when we take a difference, so it will be 13 cm cube. And in experiment 1, it was 0 and 26. So it means 26 cm cube. So the first experiment, we need 26 cm cube for a complete reaction. But second experiment, we need 13 cm cube for a complete reaction. So which experiment, the solution of a salt, which is there in a conical flask, is more concentrated? So 25 cm cube of solution A and 25 cm cube of solution B. But for a complete reaction, it needs 26 cm cube of potassium manganate, whereas for second experiment, 13. So it shows that experiment 1, the salt solution is more concentrated because it needs greater amount of potassium manganate for a complete reaction. So we have to, about 1 cm cube of sodium hydroxide was added in the flask and noted that it become red brown. So it gives an idea that iron 2 is there. Iron 2 is dirty green, iron 3 is red brown precipitate. So initial reading was 0.0 as they mentioned originally. Then it was 26. Don't write only 26, write 26.0 because the burette is accurate to 0.1 cm cube. So even it's a whole number, but write 26.0. Don't write only 26. So the difference will be 26.0. Same way, initial reading was 30. Initial reading was 16. So we'll say 16.0 and the final is 29.0. So difference is 13.0. Then which experiment was the greatest volume of potassium manganate used? So that is obvious in experiment 1. And compare the volume. So this was 26, this 0.0 and this is 13.0. So what is the ratio of the volume? 2:1. So you can say experiment 2, it is twice compared to experiment 1. Suggest an explanation for difference in volume. Means The solutions A is more concentrated than B, or solution A is twice concentrated, or require greater amount of potassium manganate for a complete reaction. Then predict the volume of potassium manganate for solution B. So solution B was in experiment 2. So from the burette, we took 13 cm cube. The difference in the volume was 13 cm cube. And the conical flask, initially the conical flask was filled with 25 cm cube of solution B. So 25 cm cube of solution B required 13 cm cube. So if we double, so 13 is to 25 is the ratio. So if we have 50 cm cube, how much potassium manganate 7 is needed? It will be X cross multiply, so it will be 26. So we predict the volume 26. Why it's of 2 marks? You have to show this working here. Like mentioned, if the volume of B is doubled, so volume of potassium manganate will also be doubled. So similar trend is there in these titration questions, that you have to state the burette reading, compare the volume, state the concentration, and predict the volume at the last. A student investigate another question. A student investigate the reaction between the solution of a deep purple potassium manganate with A and B and an acidic solution of hydrogen peroxide. A burette was filled. Now the unknown solution is in a burette. We have potassium manganate filled with the burette is filled with potassium manganate, the unknown solution. The unknown is here. And in a conical flask, we took 25 cm cube of hydrogen peroxide. So 25 cm cube of hydrogen peroxide, which is H2O2. And we did the experiment. Initially, the burette was filled with 0, and the final reading is 32. So how much A is needed? 30 cm cube of A is needed for a complete reaction with 25 cm cube hydrogen peroxide. But the experiment is repeated with solution B of potassium manganate, which is 25 cm cube of hydrogen peroxide, and the experiment 19 and 35. So we not write 19, we'll write in a value, we'll write 19.0. So 19 minus 35, which is equals to 16. So here we use 16 cm cube for a complete reaction. So if you want to find which solution A or B is more concentrated, here 25 cm cube of hydrogen peroxide needs 32. But the experiment 2, 25 cm cube of same hydrogen peroxide only need 16 cm cube of potassium manganate. So it means this one is more concentrated and this one is less concentrated. So we have to complete the initial reading for experiment 1. As I mentioned, it was 0.0 and the final reading is 32, but don't write 32, it should be 32.0. And here initial reading is 19 and the final is 35.5 or 35.0. The difference is 16.0 and difference is 32.0. So it means experiment 1, we need more of solution A compared to experiment B. Experiment 2, so the solution in experiment A is more, B is more concentrated than A. Then the question is, little hydrogen peroxide in solution in a test tube and a manganese 4 oxide was added. Rapid effervescence and a glowing split relight. So identify the gas. So which gas is this? If a glowing split relight. So this gives an idea that there is the oxygen gas. Because oxygen, the glowing split will relight. What color change observed when potassium manganate was added into a flask? So first, when we add potassium manganate will react. So initially, potassium manganate is purple in color, but because it is reacting, so initially there is no color. So from colorless, Then when there is no reaction, like all the hydrogen peroxide is used up, now potassium manganate will not react. And what is the final color? Final color will be pink. So remember, whenever you're using potassium manganate, the color change is always from colorless to pink. Why an indicator not added? So what is the reason why we did not add indicator? Because already potassium manganate is a color. So it will mask the color. Whenever we have colored compounds, we don't use indicator. So here you can mention potassium manganate is colored compound. That's why we are not using indicator. If the colorless solutions are there, then we use indicator. These are known as self-indicator reactions. In which experiment the greatest volume is used? That was in experiment 1, which we used 32 cm cube. And compare the volume. The experiment 1, the volume used is twice as compared to experiment 2, and suggest a difference. The difference is in experiment 1, the concentration of potassium manganate is lower as compared to experiment 2. If experiment 2 was repeated using 12.5 cm cube of a hydrogen peroxide, so if this 25 cm cube needs 16, but if we have 12.5, so in this experiment, 16 cm cube is reacting with 25 cm cube. But if we have 12.5 cm cube of hydrogen peroxide, it will be X cross multiply. So how much is needed? We need 8 cm cube. So the volume is half. That's why smaller half volume of potassium manganate is needed. Give one advantage and one disadvantage of using a measuring cylinder. So advantage, that we can transfer quickly. Disadvantage, not accurate. So this was another question from titration. A student investigated the reaction between hydrochloric acid and alkaline solution R contain two different substances S and T. So the same idea, what we'll do, we'll use a Burette reading complete and compare the volume of substances needed for a reaction. All the experiments are similar. You can see a student investigating sodium carbonate with two different solutions of hydrochloric acid A and B. Measuring cylinder 25 cm cube of sodium carbonate, and we add a burette is filled. So this time solution, a unknown solution in a burette. So first is A and then B. So we write the values here by reading the burette readings. Then what color change is observed? Now what will the color change? Methyl orange. The methyl orange, the color of a methyl orange, it is red in acidic and yellow or orange in alkaline. So the measuring cylinder 25 cm cube is poured into a conical flask. So in the conical flask, we have sodium carbonate. Alkaline solution is initially there's an alkali, and the burette is filled with hydrochloric acid. So what will be the color change? Because initially it is alkaline solution, so methyl orange and alkaline, it will be orange or yellow. But when we add acid, the orange color will change because the solution will turn acidic, and in acidic it will be red. So the answer here, what is the color change? It will be from orange to red. And then experiment 3 is there, repeated by using another solution B. So we just have to read the burette readings are there, experiment 1, 2, and then experiment 3. And suggest one observation other than the color change. What will the another observation other than the color change? Because we are using a carbonate react with acid. What gas is given off? Carbon dioxide. So what is the observation? We'll observe fizz, bubbles, or effervescence. And then complete the statement below. Experiment dash need the largest amount of hydrochloric acid. So we will read here, like this is experiment 1, 13.2. Here it is 12.5, 6, 7, and 8, and 39.2 will take a difference. And here also 9.9 and 16.5 will take a difference and work out which will giving the most difference, that is the greater quantity. Then what would be more accurate method of measuring the volume of aqueous sodium carbonate? So here this answer is given in the question. So instead of using measuring cylinder, what we should use a burette or a pipette. Then what will be the effect on the result if the solution of sodium carbonate was warm? Look, this reaction does not depend on the temperature because it is an acid-base reaction. So amount of the acid needed for reacting with a warm solution or with a cold solution does not have any effect. So here you will write there will be no effect, and reason for that, the reaction is not affected by temperature. Like what does it mean? If I take sodium carbonate solution in a conical flask and say it was 25 cm cube of sodium carbonate and the temperature was 20 degrees. And from the burette, when we add hydrochloric acid, the HCl needed is say 10 cm cube. Now we take a conical flask and we take sodium hydrogen carbonate, we warm this conical flask. So now the temperature example 30. But because amount of acid, the rate of the reaction is different thing, but the amount of acid reacted with an alkali, that does not depend on temperature. If we have the equal quantities, it will require an equal amount for a complete reaction. So effect of on the result, there will be no effect. And reason is that because we are using the same volume. So if same volume or same concentration is used, then there is no effect on the result. Then determine the ratio of experiment 1:2. We will take, and then which solution is more concentrated depends on which one we need. And suggest a different method using a standard lab chemicals, determine which dilute hydrochloric acid is more concentrated. So what we can do to identify which is more concentrated, so we can add metal or metal carbonate. And then we can measure the volume of gas. The one which gives the greater amount of a gas is more concentrated. So the concentration of an acid concentration changes. The change in concentration can be determined by identifying how much product is formed. Then student investigating a reaction, as you can see, like either a reaction is either sodium thiosulfate titration, potassium manganate titration, or acid base. So 3 titrations are there. So again, you have to read the burette and identify, fill up according to the questions. I will share one file in which I will mention all the precautions, sources of errors, and the things which we should keep to make this experiment accurate. Today, I will share that file with you. Is it clear, these titration questions, the format of the question?
Yes, sir.
Okay, so I'll end the session now and share the recording as well as the edited file related to all the experimental accuracies, precautions, and planning.